Namaskar. Today we will study beyond the limit. In the lecture series of calculus, we have already studied the concept of limit. We have understood that why limit is so important for understanding calculus. Already we have studied the calculus, which is nothing but study of rate of changes, and the concept of limit is very important tool for studying calculus. In the earlier lecture already we have solved various such examples so that our understanding becomes deep. Today we will study an very important theorem. Today we will study an interesting theorem, which is pizza theorem, burger theorem, sandwich theorem, cake theorem. Can you guess which theorem to be studied? Yeah, excellent. Today's theorem is burger theorem. Great. Today's theorem we will study, that is the sandwich theorem. Wonderful. This is the sandwich theorem. This is the sandwich theorem. Sandwich theorem. Delicious sandwich. Why sandwich theorem is so important in studying calculus? Why sandwich theorem is so important for determining the limit? Already we have studied why limit is studied, how limit to be computed, how limit to be found. But today, why we are studying, why we connect this very interesting and foodie theorem, very interesting and foodie concept, connected with limit, connected with pizza, connected with sandwich, connected with calculus. Now the time to deliver the lecture on an important topic, that is the sandwich theorem. This is very interesting theorem. First, we try to understand this theorem with the graph. Suppose any graph we have, maybe the first graph, curve 1, this is the curve 1 or function 1, maybe this is the function 1 or curve 1, and another one like that. This is the second curve, maybe. Then what will be the limit of this curve? 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 That is F3, F4, F5. Maybe there are infinite curves. Then, what is your guess? Can we try to determine all the limits? Can we try to determine every limit of these curves? And strangely, there are infinite curves. There are infinite functions. And an important question raised here, that is limit of all the curves same or distinct? This is an interesting question. What will be the limit of F3? What will be the limit of F4? What will be the limit of F5? What will be the limit limit of all the function same, or there are distinct limits. Why we are talking about the curves between these two functions? Why we are talking about the masala, the potato, the aloo, in between the two slices of breads, that is sandwich. Therefore, this is strongly recommended for imagination about a very delicious sandwich. Think about the sandwich. There are two slices of breads. You imagine about this is the first slice and this is the another slice of the bread. And these are the masalas, these are the aloo, and these are the very delicious twist, paneer and whatever you think. What is the role of these masalas? How we say that these all masalas will be same? This is an interesting concept. But now the time is to unboxing the secret, which were a very clear statement, that is all the curves, whatever the curve is, all the curves in between these two curves having the same limit, as the limit of this one and limit of this one. Interestingly, beautifully, creatively. This is a wonderful theorem, not only known by Sandwich theorem, but also squeeze theorem, and also the pinching theorem. All is represented the same concept. Now the time to deliver, now the time to state the statement of this theorem. In this general illustration, we have understood that what is objective of studying this fundamental and beautiful concept. Again I summarize for better understanding, that is all the limits will be same as the limit of these two curves. If the limit of both the curves are equal, definitely whatever the curves, 1, 2, 3, 4 or infinite curves, always holding the same limit value. This is an interesting observation. Now the time to state what is the statement of this theorem. The statement, the Sandwich theorem. Let, very interestingly, gx less than or equal to ux less than or equal to fx. For every x where the point C contains in some open intervals, definitely there are a point C contains in some open intervals. Then and limit of x tends to C, definitely C is any point in the real line, such that x does not equal to C. It means that itself C. This theorem not defined. Except x equal to C, this theorem is defined. Basically, this is the generalization because this is a tool for understanding limit betterly. This is an important tool for determining any type of complicated function, complex function, any type of critical functions. We can determine the limit easily by using this wonderful Sandwich theorem. Then x does not equal to C means the concept of limit adjusts limit of x tends to C, gx equal to limit of x tends to C, hx, this one, fx equal to L, this one equal to L, then whatever the function is ux, no matter is a simple function, complicated function, whatever the level of its complication, no matter through this concept of Sandwich theorem, no matter how that function is difficult, no matter how the problem is complicated or difficult or trivial also, all the time you will get the solution, you will get the limit easily, simply, trivially. How? Then limit of ux also will be equal to L with the same condition. This is an important statement for understanding not only the limit but the calculus through the limit. Again I revise this statement. There are three functions. We focus on this function only because this is defined as the objective to determine the limit. What will be the limit of ux? But given that this and this function, we are not sure, we cannot confirm what is this function, what is the characteristics of this function. But definitely, whatever the function comprised with this condition, then definitely for any real value C which lies in the real line for all x, exactly not itself the point C, but nearby the C, very close to C, then limit adjusts defined by limit of gx, x approaches to C, this one, and limit of fx with the same approaching x tends to C, it will be L, the limit value of both these functions. Then definitely, no matter whatever this function, all the function carries this limit itself, which is same. This is a wonderful burger theorem, pizza theorem, cake theorem, sandwich, squares or pinching theorem. Not time to illustrate. Someone tested it, and how the taste is, delicious. Wow. Now the time of giving example to understand the sandwich theorem. What is the sandwich theorem? Actually, very wonderfully we define any problem. Number one, given that 1 minus x square by 4 less than or equal to ux less than or equal to 1 plus x square by 2. Find the limit. Find the limit of ux, this aloo masala of ux as x approaches to 0. Solution. No matter what is ux, no matter ux is complicated, simple, hard, no matter whatever ux, we can easily determine the limit of ux. No matter how the problem is simple, no matter how the problem is so complicated, no matter, there may be infinite functions like with this ux, but all the time we able to compute the limit by using the sandwich theorem. Directly, very simply, we apply limit for this one simply by the sandwich theorem. By sandwich theorem. It says that limit of this value, limit of x approaches to 0, 1 minus x square by 4. Already we have studied how the limit class to be applied on such a functions. Then directly we know that putting the value of x 0, then we have the limit value 1. Another one, this side, this is the first slice of bread. This is the second slice of bread. And this is the aloo or masala or paneer. Interestingly, then limit of x approaches to 0, 1 plus x square by 2. Again, we know that putting the value of 0, x as 0 here, then it becomes 0. It means there is only one O. Interestingly, it means both is equal. This one and this one are equal. It indicates that, it implies that. Therefore, by the simple sandwich theorem, picture theorem, sandwich theorem. Therefore, limit of x tends to 0, whatever the function ux, no matter, whatever the function ux, no matter, all the time the limit will be 1. Interestingly, this is the answer. Anytime, all the time, this is the standard result. Whatever any function can you treat here, but all the time, if it satisfies this condition, condition, then definitely the limit value of that function will be the same occurs for both these slice of breads. We can understand this thing. This is the answer. We can understand or we can generalize this concept with the graph also. This problem transform in graph. Simple x and y. Now this is 1, 2, minus 1, 1. And the graph of this one, this function is that. And the graph of this function like that. This one it is represented by this graph. This one is represented by this curve, and this one is represented by this curve. But now the question, what will be the ux? No matter what will be the ux, anything, any functions, any equation, any problem, any functions, but all the time we have the same value. It means that the function may be this, the limit will be 1. The function will be this, the limit will be 1. The function will be this, so complicated, no matter, the limit will be 1. The function will be this, no matter, the limit will be 1. The function will be, there are many options, there are many possibilities, there are infinite curves, but sorry, by sandwich, all carries the single limit, whatever the limit of these two functions, the answer will be the same of this function. It means the limit of this function will be same, which one is nothing but the same limit of these two functions. This is, oh sorry, now I am going to taking the sandwich, delicious sandwich. Definitely I am also suggesting to you, go for sandwich and understanding this theorem in the table of sandwich, offer the great sandwich and study this theorem also with sandwich. What is the taste? Please share on your comment. Thank you.